Welcome back. Today we're going to talk more about polygons. Today we're going to talk about the constructor. And if you remember from our first lesson about polygons, when we picked up polygons that we made with the box of sticks, some of those polygons kept their shape and some of them did not. And the ones that kept their shape are called the constructor, the triangle. The triangle is special the way that it is built, the way it has the three vertices or vertex points where it turns on three spaces and the three lines. So the triangle is one of the most powerful figures of all, and we call it the constructor. So I want to talk to you more about different types of triangles because we classify triangles two different ways. We can classify triangles based on their angles, the angles that make up the triangles, and we can also classify triangles based on the sides. So first we're going to talk about classifying triangles by their angles, which we've done a little bit of when we talked about angle work and what it means when we measure angles. And some of you might remember that we talked about if we have a line and another line and they come together, the space between is the angle. And if we have an angle that's less than 90 degrees, we call that an acute angle. And if we have the space between two lines that makes 90-degree angle, that's called a right angle. And if we have space between the angle measure between those two spaces is greater than 90 degrees, it's called obtuse. And we talked about triangles keep those same names. So I want to show you a couple examples of those triangles. So let's switch our view. And here I have a triangle whose angle measures are all less than 90 degrees. If I place this on there, you can see there's paper sticking out still. So this triangle, the angles that make up this triangle are all acute angles. This is called an acute triangle. Acute triangle means that all of the angles that make up the triangle are less than 90 degrees. Just like when we measured acute angles are all less than 90 degrees. Okay, here I have another one. This one here is a triangle. It has 1, 2, 3 sides. And this angle here looks like, if I place it on our angle measurer, that it covers up our whole angle measurer. This doesn't count up there, but our angle matches our angle measurer. This one has one right angle. One right angle makes this a right angled triangle, a right triangle. A right triangle has one right angle. All right, now we have this one. This one here is a triangle, 1, 2, 3. And if we place our angle measure and set it right on there, you'll see that this extends way past our 90-degree mark. A triangle that has an angle greater than 90 degrees, we call obtuse. An obtuse triangle has one angle that is greater than 90 degrees. An acute triangle has all three angles less than 90 degrees. A right triangle has one angle equal to 90 degrees. And an obtuse triangle has one angle that is greater than 90 degrees. Okay, I am going to pull those down for a moment. Actually, let me leave them up so I can take a quick picture. And then now I'm going to pull these ones off, and I want you to see some different names for these triangles. Actually, I can leave these ones out just like this. I'm going to set these ones off to the side, and we'll start with this one here. Now we're going to look at these triangles by their sides. We already talked that this one has three acute angles. This side and this side and this side are what we're looking at. We're going to look at this side. So let's look at our frame, and we're going to rotate this. Those sides are the same, and those sides are the same. All of the sides of this triangle are exactly the same. When we have a triangle that has three equal sides, we call that an equilateral triangle. Equa means same, and lateral, lateralis, sides equals sides. So an equilateral triangle is a special triangle. All angles are the same, and all sides are the same. Okay, let's look now at what we used to call our right triangle. Now we're going to talk about it based on its sides. what I'm seeing here is that this side is long and these sides are the same. These sides that are the same, there's two of them. There's two sides that are the same. This is called an isosceles triangle. An isosceles triangle has two sides or two sides. This one's a base and a side, two sides that are the same and one that is different. In this case, this side is longer. It doesn't have to be longer than the other two. It could be shorter. Two of them just have to be the same. Iso means same, and the root for this is side, equal sides. These two are equal sides. Or, I'm sorry, this isn't sides. We had sides lateralis. This one is legs, equal legs. The root of isosceles is the same root as like skeleton, skelos, meaning leg. So equal legs. All right, let's bring this one down. So this one here, let's take a look at this one. This one here has two sides and one really long side. So these ones here, let's just kind of check it. Ooh, those are the same too. This one here, our example we used for an obtuse angle, is also isosceles. Do you think in our box or our drawer of triangles that we have another isosceles triangle? Let's see. Let's see here. We're looking for a triangle that has two sides that are the same. And these are the ones that are left. This one doesn't match. This one does though. This one and this one are the same lengths. So this one is also isosceles. Interesting. We have three isosceles triangles. This one has the third side shorter than the two sides that are the same. And those ones both have the other side being longer. Okay, those are isosceles triangles. Let's see. What happens if we have a triangle that has all three different length sides? When we have a triangle with all three different sides, this is called a scalene triangle. A scalene triangle comes to us from the Greek skelenos, meaning uneven. Not skelos for skeleton, leg, but skelenos, meaning uneven. So a scalene triangle means uneven, or the three sides are all different. So scalene triangle has all sides being different. We have a couple more examples of scalene triangles. This one here, you can see a long side and a shorter side and an even longer side. And here we have another scalene triangle that has the shortest, a medium, and a really long side. What's really cool about triangles is we can classify them both by their sides, like we've done here, and also by their angles. And we can do that at the same time. When we have an equilateral triangle, it's always equilateral. We don't have to call it an acute equilateral because an equilateral triangle always has three angles that are less than 90. So you would not call that an acute equilateral triangle. But we could find an acute isosceles triangle. Let's find an acute isosceles triangle. All angles are less than 90. So this one has a 90, so that one doesn't work. And this one has one that's greater than 90, so that one doesn't work. There it is. Here's an acute isosceles triangle. How about if we wanted to find an acute scalene triangle? This one here, I can see it has a right angle, and this one here, I can see it has an obtuse angle. So this one here is our acute scalene triangle. We can do the same thing. I'm going to set those ones out of the way. We can also find a right isosceles triangle. These are our isosceles triangles up here. We can find one that is right isosceles by the one that has a right angle. this one right here. We can also find an obtuse isosceles triangle. There's an obtuse angle triangle, and it's also an isosceles triangle. So you can see that we can classify them simply by calling these isosceles. We can get much more specific by calling it a right isosceles triangle. We can do the same with our scalene triangles. Let's pull our scalene triangles back up here. We look, for me, I like to look for the ones that are easy to recognize. So I can say really quickly, I can say, oh, this looks like a right angle. So this is a right scalene triangle. And then I look, my next easiest one to look for is obtuse. If I'm looking for an obtuse scalene triangle, I look for the one, sorry, I didn't realize you couldn't see that. I look for the one that has a greater than 90-degree angle, and that's this one. There's my obtuse scalene triangle. And if I am looking for this last one, all of my angles are less than 90 degrees. So I would call that an acute scalene triangle. So you can see that there could be lots of games you play with different kinds of triangles. There are so many different types of triangles. Well, actually, here they all are right here. There are 7 types of triangles, and you can name them different ways. I can't wait to share more with you about triangles because there is so much to learn, and triangles are so much fun to classify. In your journal, you're going to draw the 7 triangles, and you're going to label them using both a side description and an angle description. So you'll have, you'll use right, obtuse, or acute, and also isosceles or scalene, and you'll have an equilateral triangle as well. I can't wait to see your follow-up. I'll see you next time. Bye-bye.